With geometry scripting, we can do a lot of cool stuff, like for instance, put in a blueprint where we can simply very easily do this, and just like that, we've made a floor. And if we move this bool location around here, and we select a mesh to cut out of this floor, so for now, let's just go for a cube. We can then change the scale to go with up, and now we've got a floor with a very easily made hole in it. We're going to be recreating this today in a new project. So first things first, in your new project, you're going to go into your plugin browser and you're going to look for geometry scripting. It's tagged as experimental because it's still in development, of course. So you're going to turn that on and you'll restart the engine in order for everything to be in the proper places. Then we can make a new blueprint class, and we'll make one of type generated dynamic mesh actor. It is worth noting that the generated dynamic mesh actor does not build into your packaged games. So if you put these into your level, if you make your entire levels out of these, they're not going to show up in your packaged games. You're going to need to bake them into static meshes for them to show up. The normal dynamic mesh actors will show up in your build, but they lack one feature that we're going to be using here. So use a dynamic generated mesh actor and then bake them into a static mesh. I'll show you how to do that in a moment as well. And let's call this BP block builder. Here we're going to go into the event graph. We're going to get rid of begin play and overlap and all that stuff. And what we're going to do instead is we'll add on rebuild generated mesh. This is kind of like the construction script in that anytime you update the generated mesh that we're going to be making, this event will rerun. So the entire thing will rebuild. This is just a little bit more performance than running the construction script. So that's the whole reason that we're going to work with this over using the normal dynamic mesh actor and putting everything into construction script. That is a totally valid alternative as well. Now, this target mesh output that we have here is going to be the mesh that is going to be created through this blueprint. So we can do whatever we want with it. We can add new meshes to it. We can do Boolean operations on that mesh and whatever you want to do. If you've ever worked with geometry nodes in Blender, this is quite similar to that in many regards. So the first thing we're going to do is we're going to append a box. And you can see there's a bunch of things we can append. We can append a box, capsule, a cone, a curved stairs, a cylinder, a disc, and just so many different basic shapes that we can be working with here. And there we can put in the dimensions that we want. We can say how many subdivisions we want. We can say whether or not we want it to have its pivot points on the base. So that will be the bottom face in the center or in the exact center of the entire box. And then we also can have a offset transform, and we have some more primitive options, which I don't really care about right now. So if we just put this into our world right now, we can see it's already just a box because we just appended that box. The pivot point is on the base because that's what we set it to. But we can't really do anything with it yet, so this doesn't seem too useful. And for that, we're going to add a variable here. And that will be our corner location, which will be a vector. And if we compile that and we set that to being public, we can set it to show a 3D widget. That will create those little handles you saw in the demonstration at the start of the video, where we can, in the viewport, drag things around a little bit, which is really, really nice. By default, let's set this to 100 or 100, 100. And now we can see we have that little handle here and we can move it around and it changes our vector of value, which is really, really nice. We're going to be using this in order to set the dimensions in the X, Y, and Z for our box. So let's pull this out here. We can split the structure pin into an X, into a Y, and into a Z. And now we can see we have that little handle, and when we move it around, it changes the shape of our box. Do be careful not to change it into negative values though, because at that point the normals will be flipped, and that's generally not something you want. Unless you do want an inside-out box. Like if you want to make a room that you can stand in, that you can make in this way, of course, because the normals will be flipped. But largely we're going to be using it in this way. So what we could do is we could clamp this to only ever allow for positive values. But for now that's a little too bothersome, so we're not going to deal with that. Next up we have another problem, and that is we called this corner location, but it is most definitely not the location of the corner. And that is because the pivot point, and as such the directions that these dimensions grow in, is set from the center of the base, meaning that if we move this thing 100 units to the right, it's only growing 50 units into this direction and 50 units into the other direction. So we're going to need to offset this box so that the origin point is on the opposite corner. That will fix our offset there. The neat thing about these geometry scripting nodes is that we have this target mesh input, and then it also outputs the target mesh again. Effectively, this is just the same value that it's outputting. It's both just a reference to that target mesh. But this way you can very neatly chain things from one node into the next, into the next, into the next. So that's quite nice. And if you're working in a newer version of Unreal, this is Unreal 5.1, so this node apparently doesn't exist yet. But if we have 5.3 here, I want to show you, there's this node called Translate Pivot to Location, which is exactly used for changing the pivot location of your mesh. And with that, we can just get our corner, make it into a negative number, either by subtracting it from 0 or multiplying by -1, and then multiplying it by 1/2 or dividing it by 2 and putting that into the pivot location for the X and the Y. We're going to just do this through translation instead. So I'll just get all of this stuff out of that other blueprint that I just showed you in 5.3, because again, apparently that node does not exist in 5.1. And a different way to deal with this is splitting our transform pin and splitting our location pin and just doing this through our location translation. So we get 0 minus X multiplied by 1/2, and that seems to work the exact wrong way around. So we don't need to negate them, we only need to divide them by 2. And now we have the corner variable actually on the corner of our mesh, and we can very easily like make a box like this and do whatever we want with it. But now this just allows us to create a box. It's been quite bothersome for something that just makes something this simple. So let's add in something where we can add in a mesh of our own, any shape we want, and use that as a bool operation on this thing. First things first, if we want to use a bool operation, we need to allocate a compute mesh, which is a specific type of mesh variable that is used to, well, compute things. So it's not used to show anything, it's just used to calculate how it impacts other things. So we can allocate a compute mesh, and then we can put in any dynamic mesh we want from here. So that could be another one of these append boxes, that could be an append cylinder, that could be whatever we want. But for this example, what we're going to do is we're going to copy mesh from static mesh, because this will allow us to put in a static mesh asset, which we're going to promote to a variable, and we're going to expose that. And this will generate a dynamic mesh from that static mesh. It's important to note that dynamic meshes aren't assets. They are formulas. They aren't stored anywhere in your project as an asset like a static mesh would be. And that's why you have to convert a static mesh into a dynamic mesh. You take the static mesh asset, then convert that into just calculation information, and then you can use that as a dynamic mesh with this node. If that is successful, if it for any reason fails, you don't want to use this dynamic mesh, of course, but if that is successful, we want to apply a mesh boolean operation. And we want to use that dynamic mesh that we got out of here as our tool mesh. And then we want our target mesh to be whatever the output of this append box is. Again, what you could also do is just make this into a variable and reuse that variable. It's just a pointer, so it will work regardless, but this just looks a little neater having everything linked up like that. So we can just do that, so everything is a little bit more visually appealing. Then we can choose whether or not we want this thing to be a union, so putting both of those meshes together into one mesh. We can say the intersection, which will cut everything out that doesn't have these two meshes overlapping. And then we can subtract, which is just subtracting the compute mesh from the dynamic mesh. I'm going to just show you all three of them in a moment. But before we do that, we need to, at the end of this, since we allocated a compute mesh, we need to release that, because otherwise it's going to keep allocating new memory for these compute meshes, and that then results in a memory leak, which after like half an hour of working in the engine, your engine is going to slow down and you're going to get like pop-ups saying that you're doing something wrong. So you go to the end of here and you just say release all compute meshes. You can also individually release the compute meshes if you're doing something more complex and you need to worry about freeing up some more memory to allocate some new compute meshes. By and large, just at the end of your entire thing, releasing everything works fine. One last thing that we're going to do is we're going to promote this target transform to a variable as well that we're going to expose. And transforms, much like the vector that we saw before, we can turn into a 3D widget. That way we can move around our Boolean mesh in the world. Do make sure to put it into the right transform though. I put it into the target transform before. You want to put this into the tool transform. And you can see with it on subtract mode, it is subtracting that sphere from this mesh over here. If we put this on intersection mode and we compile again, the entire mesh will disappear except where they are overlapping. And if we put this on union mode, they will just both show up as part of the one mesh together. Usually with a bool operation, 9 times out of 10, I use it for subtracting something out of something else. So we can very easily make like a crater in a wall or something. And you can go crazy with this if you want to, right? We can, instead of doing that, and I'm just going to go real quick here, instead of just using a target transform, what we can do is we can turn this into an array, and we can use this for a for each loop, and we will allocate compute mesh and do that entire thing for every iteration here of this array. And we'll use these array elements as the tool transforms. And now we have this target transformation array, and if we make like 3 of them, we suddenly now have 3 of these spheres which we can use to do some bool operations. So we can take a little bite out of it here, and we can take a little bit out of it a little bit further down the line up here, for instance, and we can just very creatively keep going and make something like a Swiss cheese type of wall. Now, one last thing, after you've done all of this, you want to play your game, and if you just play your game, it's right here. It doesn't have collision at the moment, which is quite relevant. But if you were to package this game, this thing wouldn't show up at all. So the easiest way to go about doing that is to go into modeling mode up here and simply go on the transform with this asset selected to convert, and convert it to a static mesh. That will just make a static mesh out of it, which now will just appear in your game and be built. And it will also just have collision now, which is quite important. What you could do is we can drag in another one here, and let's just make another one of these walls, for instance. You could also make a function to do something similar. This is a little bit overkill, but I do want to show it off. What you can do is just make a new function and call this create static mesh asset. And this is another reason why we're using the generated dynamic mesh actor, because this is going to create a new asset in our project. And since this class is editor only, it has a node made for that. which is really quite nice. So the way we do that is we get our dynamic mesh as it is right now. Then we create a unique asset name and path. This one, create new asset path name. There we put in the asset folder path. You can make this into a variable if you want to. What I tend to do is just put them into a folder called this, /game /levels /_ generated, because that is what the engine uses by default as well. If this folder doesn't exist yet, it will just make the folder. Then we can add the base asset name that I do like to promote to a variable here, and just give it a default name of mesh _. If you put something else in there yourself, it's going to give it that name. If not, it's just going to give you mesh _ and then the number of the mesh that you generated. If it's successfully made that new asset path name, you can then use that to create new static mesh assets, and there we use our dynamic mesh as well. So we'll get our dynamic mesh return value, and we'll put that into our dynamic mesh. We'll get our unique path and name, and put that into the asset path and name. And here we want to make our geometry scripts create new static mesh options, and there we want to say enable nanite. For the most part, you're going to want to have nanite enabled on most of your static meshes. And we can even get a make node for this little struct over here as well for the nanite settings, and we enable it there as well. Then once we've made that static mesh asset, what we want to do is we want to remove this dynamic mesh asset that we've been working on and replace it with that static mesh, right? So what we can do is we can spawn actor from object. You're probably used to the spawn actor from class, which is fine. That's what you usually use when you're spawning in like enemies or something like that. In this case, we're spawning an actor from an object, which is more of a thing that you do in scenarios like this where you're working in the editor. And we're going to spawn a actor from that new static mesh asset that we've just made on the exact same location. So get actor location, and that will just effectively replace our dynamic mesh actor with a static mesh without us having to do all of that going into modeling mode and stuff. Finally, we destroy this dynamic mesh actor because we no longer need it. There's entire systems you can set up where it keeps the dynamic mesh with a link to its newly created assets, and you can switch them back and forth and stuff like that. It's a little beyond this video right now, but that is a very, very useful, powerful thing to do. I would recommend, if you're into that, go download the Lyra project from the Unreal Marketplace. That has a system like that, which is very, very well made. Now, the last thing we want to do is we want to highlight our function we just made, and we want to enable our call in editor here. That will enable a button in the editor that will run this function for us. So if we go back into our third-person map here, and we scroll down a little bit, I really wish there was some way to say that it should show up on top with those buttons and all those variables. But if we scroll down a little bit here, we see our create static mesh asset. And when we do that, you can see it removed the dynamic mesh, and now when we select it, it's just a static mesh. So that's also a way you can go about doing that, and honestly, it's a lot easier to do it that way than having to go into modeling mode every single time you want to do something like that. And as always, if you want to check out these project files to play around a little bit with the geometry script you've seen here, there's a link down below in the description to my Patreon where you can download these project files to play around with. And just as a little bit of a bonus, we're going to add something to this to turn this into a ramp rather than a block. So opening up that block builder thing over here, what we'll do is we'll get our dynamic mesh and we'll apply a mesh plane cut. We'll only do that if a certain bool is set to being true. So we'll make a bool here and say is ramp. So for now, let's put it before the for each loop. The cut frame is the position and the scale and the angle at which this mesh will be cut. And only one of the sides of that plane will end up showing up. So it's kind of like a bool operation, but instead of cutting out anything that is overlapping with another mesh, it will just cut out everything on one of the sides of a plane. So for that, we will use the find look at rotation, because the only thing that we're going to care about here really is the rotation. So we'll plug that into the cut frame rotation, and our starting location will be just 0, 0, 0. So we'll make a vector and keep everything at 0, 0, 0. Then the direction that we will be looking at is the direction of our corner location, but we don't want to actually look at our corner location. Let's go back into the third person example map here to show you why. Because the corner location is at the exact opposite end of our mesh. And if we make a plane cut this way, it's not going to end up being a ramp. It's going to be a block that's cut in half diagonally. What we want to do is we want to cut it in half from the bottom left here to the top right, not from the bottom left here to this top right. So instead, we will be looking at a location here, which has the same Z and X coordinate as our corner location, but a Y coordinate that is just 0. So for the target, we're going to split the structure pin, we're going to split the corner location, and we're only going to hook up the X and the Z locations. Now, if we reconnect that, we will see we have a ramp. So we can very easily make a ramp. And if we put in the Boolean variable that we made and put a branch in there, if we make this, if that is true, we apply the mesh cut. If it is false, we're going to go straight into the for each loop. So now you can see it's set to false. If we scroll down a little bit and find the relevant variable, we can apply isRamp and it just makes a ramp out of it. Now, let's take a look at adding these target transforms like we did before. We can still move this around and cut out any part of this ramp that we want. And of course we can make this as complicated as we would like, or as simple and easy as we would like, but this is the basic idea of geometry scripting. So next time I'm going to do a separate video on making a doorway or an archway or whatever you want to call it, because that's also a very fun implementation of all of these techniques in a slightly different scenario. So do get subscribed if you haven't seen that yet. And again, the project with this asset pre-made inside it is available on my Patreon for those of you who want to play around with it. And a very big thank you to all of my Patreons. You can see them on screen right now. If you want to help out supporting the channel, there's a link down below in the description to the Patreon page. And a special thanks to my Cave Digger tier Patreons, Sir J. Thomas,